Good evening, everyone. Welcome to another installment of Lambda School's free mini bootcamp series. I will be your instructor tonight. My name is Dan Frainer, and tonight we're going to be building a game with JavaScript. So a couple of things that I'd like to lay out before we get started. If you are planning on following along tonight, that's fantastic. I hope anyone that is able to follow along does. If you do want to follow along, there's going to be some things that you should know. This is not a beginner, strictly a beginner level class tonight. It's a little more intermediate. So you should have a fairly firm grasp of JavaScript tonight. You should be able to write components and use state and props in React. And then we're also going to be using some React hooks tonight, specifically use state and use effect. So if you're comfortable with those things, you should have no problem following along tonight. Things you don't need to know: game design. We have kind of laid most of the stuff out, and we'll be going over the logic of the game as well as we're building it. You don't need to know the CSS. There's some tricky CSS in tonight's stuff. But we've built all that out for you ahead of time. We will be talking about some of that CSS, but no worries if that's not your forte. That being said, if you are a beginner, this next hour is going to be, there might be some points when you're confused a little bit, but you're going to have fun, and you're going to understand how things work behind the scenes. So if you're interested in web development or in JavaScript, React, you're going to see some of the stuff that you'll be able to build. And here at Lambda School, something like this is something we would build only probably 4 to 8 weeks into the program. So the skills you see here are fairly intermediate, and this is just the tip of the iceberg as well. The cool thing about web development and React and JavaScript is we can build everything. Everything from Facebook to a little memory game like we're going to build tonight. So if you are a beginner, by all means, hang out and soak as much in, and see what the possibilities are to build things in the future. So that being said, I am going to jump right in and show you what we're going to be building tonight. So we're going to be building this memory card game. All right. We're going to see in our iteration of it here, there are 20 cards on the screen. By the end of the class, you'll be able to build a game with as many or as few cards as you'd like. And so what I've done here is I've just put a series of emojis on the back of these cards. And every time I select 2 cards and they don't match, our score is going to go up. So the point of this game is to have as low of a score as possible. So the lower the score you have, the better you did at the game. So let's just check it out for a minute. We got the classic burrito, probably one of my favorite emojis on there. And the happy, laughing, crying face. And notice that neither of those match, so they got flipped back over. So you got to remember that the happy, laugh, cry face is right there, and the burrito is right there. I probably will not remember that. I am not great at this game, by the way. I can build it, but I'm not the best at it. All right, we got dog, pretzel. Let's see if we can match a couple. Oh, boy. I'm not getting any. Pretzel. There we go. All right, we got pretzel and we matched them. So now we see that we had 5 misses, okay? But that pretzel was our first hit. I'll try to do this as fast as possible. Maybe we can get through it super quick. We got burrito. Yes, beautiful. Believe the other rainbow is right there. That's right there. Burrito's right there. All right, let's see if I can do this fast. I think my top score is like 14, so if I can beat that, I might be able to. I did. And now you'll notice that you win, and you'll have your final score displayed. There's some bonus things that we're going to talk about that you could implement. with this this game, you can do a lot of custom things to it. You're going to build it, right? And so it's your game, and you can take it and you can build it all you want. All right. So what we're planning on doing over the next hour is building this, what you just saw. And then, like I said, you can take it to the next level if you want. And I have some suggestions for that going forward. So we are going to start off in a online code editor called Code Sandbox. And Code Sandbox works really well if you're developing React stuff, I've found. And so there is a link. There should be a link given out. And you can find the link right here. I hope it was given out to you all. It's not the most, I guess, codesandbox.io/s/lambda-school-fmb, which is free mini bootcamp, -game-starter-vylky. You can, if you travel to that URL, you can click on this fork button right here, and it will create a new version of this for you. So you can actually code along and build along with me tonight. So travel to that URL and click the fork. All right, first thing I want to go over is some of the things we've got going on here. I'm going to kind of make that screen a little bit smaller. And let's look at our source package or our source directory here. We've up our React application. We've got our app, which right now is doing a couple things. It is importing our CSS into here, and it's also just essentially putting that H1 on the screen there. And it's also got a class associated with it as well of app. Okay. There's a couple other files over here that I would like us all to look at. First is the styles.css file. So remember when I said at the beginning that CSS, you would not be required to have a good fundamental knowledge or focus on CSS. It's always good to have it. I assume if you have knowledge of React, you have a little bit of understanding of CSS, but we're not going to write the serious CSS. That has been written for us. I'm going to reference this file as we use some of these classes and IDs in here and talk about what something like that means, right? But we're not going to have to write that tonight. Okay. So a lot of the CSS has been written for us, and most of the CSS is stuff like colors, positioning things, giving it a border, giving it a drop shadow. So if you're interested in CSS, by all means, if you're like, oh, how did they, put that drop shadow down? Come in here and check out the CSS. All of it's in here, available for you to inspect on your own. Okay. And like I said, we're going to come back to it as we use it. The next thing we're going to see is we're going to have a cards data.javascript file. And what this is going to contain is it's going to contain a data set for the cards we are going to use. We'll go through this stuff again, but really it's a JavaScript array. And in that array are a number of objects. Okay, and these objects all have a value, which is going to be the emoji. They're going to have whether it has been flipped or not. And then it's going to have an ID to it. Okay. And so you'll see that there are 20 in here. And finally, at the end, we are exporting so it is sort, but we're actually unsorting them. We're randomly sorting them. So essentially we're shuffling it by using this little math.random trick here. So that's going to assign each card a random number, and then it's going to sort by that number. And so every time it does this, every time we load this program up, it'll be a different value. It'll be a different order for the cards. All right. We have a components directory. We don't have anything in there yet. And then let's go look and check out our public. And there's a couple of things I've added in here. Actually, one thing I've added in here. And that's just downloading a couple of fonts here. The rest of this is your standard Create React Lab or Create React app. Boilerplate code, but I've added this link to download these fonts. Yeah, that's where we're getting these fonts from. These aren't system fonts or anything that's preloaded up into Code Sandbox. All right, now that we've kind of gone over what we've built or what we have to work with, let's start to break down what we want to end up with. Okay, let's go back to our actual app. I'm going to refresh it. And let's think about what this app is made up of. First and foremost, it's made up of 20 cards, right? These 20 cards are all kind of the same. So we can consider this one card its own component. Okay, so we're going to create a card component. We also have 20 cards as a whole, okay? And so that can be considered our deck or our game board. And that we're going to add some logic to that game board and that deck to understand which cards are matching, which ones are flipped over, which ones aren't flipped over, right? Second, we have this score box here. Okay, this score box is going to keep track of how many unsuccessful flips we've had of our cards and give us a score. Remember, we want the low score. Okay, this is like golf. We want that low score. The low is the good score on this one. All right. So now that we kind of know what our game is made up in smaller pieces, we can start to create those pieces one at one. So at first, let's create that card. Okay. So I'm going to come in here. I am going to come into our components and I'm going to create a new file. I'm just going to call that card.js. This will be our card component. Unfreeze it. Oh, I hope that all of you were okay with getting that. All right. So in here now, we're going to import React from React. And we're going to export default function. And we're going to use functional components today solely because we are using hooks. Card. And we're not going to worry about props on that card quite yet. Okay, so we want to return something that looks like this card. All right. So let's return. We're going to give it a div. We're going to use a lot of divs for the card. Class name. And the class name is going to be card. Okay. Close that div out. And then let's just come over. We'll save that. We'll come into our app and we will import that card. Card from components / card. All right. So we're not getting anything on the screen yet because that card is kind of special. So in order to get that like flipping around type thing, we are going to need to give it some extra little pieces in there. All right. And so we want to give it these essentially what this card is the card itself is a container for two sides of the card. So we're going to have this front side of the card and then we're going to have a back side of the card. All right. And when one is showing, the other will be hidden. And then when it flips over, that one will show and the other one will be hidden. So it's kind of a little CSS trick to get this card flipping type thing going on. But let's just build the card right now. So we're going to create another div, give it the class name of card inner. Okay. Another close. And then inside of that card inner, we're going to have our front and back. So we're going to go div, class name, card back, close that div, and then as a sibling, we will have another div, class name, card front. So now that we have our card built, and I'm going to just copy paste that little heart emoji. By all means, you can use whatever emoji you want to signify your brand of cards on there. And let's come back into our app, and we are just going to see if that card will display. Oop, got to give it the right name. And we have a card that displays on the screen for us. All right, we are our first step into building this. Okay, so we have this card, but notice when I click on it, it doesn't flip. All right, so we need to give it this idea of flipping. All right, so it needs to essentially be the state of that card. All right, so those of you that are familiar with React understand that the state is what what controls the UI in React. So if we change the state, it can change the UI based on React, and React does that for us. So what we want to do now is we want to just give it a little flipped idea. Okay, so I'm going to create, I'm actually going to create some state on here, and we're actually going to delete this state later on. But for now, this will, and actually, let me just do it on the card itself. That way we can come back to it. So I'm going to, or on the card JS, and I'm going to use state, and I'm going to say flipped or no flipped, flipped, and then we'll have set flipped. So if you're familiar with the use state hook, we're going to set it to false at first. If you're familiar with the use state hook, we know that we can give it whatever value we want as our initial state, and then we'll have whatever the value of the state is at that moment is the first item in that array that's returned to us, and a function that allows us to change that state is the second item in the array for us. So let's do this. Let's go on click. And we're going to set an on click on this card that is going to simply set flipped to whatever the opposite of flipped was. And let's actually just set that to true for right now, just so we can see it work. Okay. Still doesn't work because we need to add one other piece to this. And so we're going to add an inline style to our card inner. All right. So we're going to say style in our card inner div, and we're going to give it the style of a transform. If you're not familiar with transforms in CSS, it allows us to change the position aspect in many different ways. But in this case, we're going to change it as a rotation on an axis. All right, so we're going to check to see if it's flipped. If you are familiar with React, you're probably familiar with ternary operators. If you're not, this is just a compact if statement, okay? So if it is flipped, that's what we're saying. If this, then do something right here. Otherwise, and we'll have that colon, otherwise we don't want it to do anything. We want it to only flip if it's gonna flip, okay? And then we're gonna say rotate Y. So the Y axis is what we want it to rotate on. Once again, this is CSS and a little outside of the scope of the lesson itself. We're really focused on the logic of the game. But what this is going to do is it's going to rotate it on its Y axis. So its Y axis is going to be that up to down axis. And so it's going to rotate it based on that axis. And we're going to rotate it 180 degrees. And there we go. Okay, so why did it flip on us? All right, let's check it out. We got it on click. We didn't click it yet. We have use state false, transform flipped. Let's just refresh that. Shouldn't flip until we click it. There we go. Now we'll click it. And we got it to flip. All right. Ooh, almost there. Okay. In this case, like I said, I want to set it to the opposite of whatever flipped was. And so now I can flip it back and forth. So this is all coming from this state. All right. And I know I kind of moved fast through this, but it's all coming from this state. So React is going to keep this state in memory, and it's going to check to see if that state changes. So if flipped is no longer false, then it's going to check to see where it is the UI is changing, and in this case we're going to add a style to it. So it'll change that, and then using CSS we're going to say, is it flipped? Then do this. Otherwise, do this. And CSS is actually doing the rest of the work for us. All right. All right. First component is down. For those of you that are following along, I'll just leave this on the screen for just a minute. Give you a second to catch up. All right. So next thing we're going to do is we want to now create the whole game board and all of the cards, right? So what we're going to do is let's just come into our game board here, or our board, and let's go into our components and we'll create a new game board.js. So in this case, we're going to import React again from React. And then we are going to export default a function that we're going to call game board. All right. And then we're just going to, for now, create a div. Give it a class name of board. Close that div out. Return that div. If we don't return anything, it's not going to show anything on the screen. And then we'll just leave it at that for now. Nope, let's do this. We're going to import the card. So we'll just have our card go through our game board here from card. Okay, so then we'll just do our card. And when we save this, we'll need to save that. We'll come in here, and we're actually going to replace card in here with our game board. And instead of card, we're going to have game board. So now we should see our card is still there. But actually now it is surrounded, it is wrapped in this game board component. Okay, so our game board is actually, around here. We have a class name on it called board. You can go check out the styles. There are styles, even though it doesn't look like there are on it right now. We can see some of those styles if we do add another card. We have some padding between the cards, and there's some borders and margins going on, and it's centered on the screen. Okay, so we have the ability, and when we look at this, both of these cards, because they contain their state, they maintain that state is different. All right. So now we don't want generic cards in here. We want the actual cards in our cards data. All right. I'm going to delete those cards for now, and I'm going to import those cards. And where I'm going to import those cards is going to be our top level in our app. This is an architecture choice, okay? We have to understand where we want to gain access to these cards because of the fact that we have a game board and a scoreboard. We want both of those things to have access to the cards. We're going to check our cards for that score. All right. And if we put it on the game board, then it's going to we're going to have to build a function to pass down as a prop to get that information back up to app. When in reality, we can just put it in app.js ourselves. So what I'm going to do is I'm going to come down here and I'm going to put in a little, I'm going to import, I'll call this, let's go deck from, and it's going to be cards data dot. It's the same directory where we're in and cards data. Okay. Now I'm going to create some state for that data. And why we want to use state here and not just the deck is because we want to change things about these cards. Remember, that data has something like flipped on it. Okay, we can change flipped from true to false and really remove the state from that card itself. So we want to change this data, and because we want to change this data, it's not going to be static data. We want to create some state for it. All right, we'll call this cards, and we'll call this set cards. And we're just going to plug that deck in to there. Okay, so now that deck, that information, that data in there is now part of our state. All right, so React is actually going to make a copy of all that data, and then we're going to be able to make copies of it and change it, and then have React react to those state changes. So we're just going to add a prop on our game board called cards, and we're going to pass cards in there. Okay. And let's get rid of cards data. Let's go to our game board. And now we have a prop called cards. Okay. I'm going to do a little bit of code styling in here. So if you're familiar with React, you're familiar with passing in a piece of data, usually in the form of an array, and then mapping over that array. Instead of writing card out 20 times, we can actually use the .map array method. So we're going to take our cards, and anytime we write raw JavaScript in our actual program here, we need to use those curly braces. That tells the JSX that this is JavaScript and this is not JSX. Okay, so we can say cards dot map, and if you're familiar with the .map method, it's going to allow us to iterate over each item in that array and transform it into something new. Okay, and in this case, we're going to take an individual card, and we want to return our card component with it. So if that worked out, we should now have 20 cards on the screen. All right, they don't have anything on them yet, but we now have 20 cards on the screen. Oh, this is starting to get good now. We're starting to build this board out. All right. So because we have these 20 cards on the screen, we want to pass that individual card data to each of these cards. So the cool thing about a component is it's this shared behavior, this shared UI, but it's going to have individual value to it. All right. And so we can actually pass that down. We'll pass the whole card down to our component, our card component. And now in here, we get that card, that single card. For each of these will get their own individual card. All right. And instead of saying set flipped to flip, we're actually going to remove that state from here now, because we're going to be using that card data, remember, that flipped value there. And we're going to change it elsewhere in just a minute. And we're actually going to remove this as well for now. But we're still going to say card.flipped. All right. And then we're going to say, in here, we're going to say card.value. So we're not going to be able to flip them yet. We removed that functionality, but just to see that worked, I'm just going to say true on here. And we'll see there that all those cards flipped around, and we can see that they each have their own individual value. And just to show you the shuffle happens, remember those two lovey-eyed faces were in the middle, and now they're in different positions. Okay. So almost done with the card flipping, the card itself, I'll say. So now is going to be where the logic comes in for our game. What we want to do is we want to make sure that we can flip a card over. When a card is flipped over, we want to check if another card is also flipped, right? So we want to look to see if another card is also flipped over. If it is, if another card is flipped, check to see if they are the same card. All right. If not, flip them both back over. If so, keep them both flipped. And we're also going to increment score by 1. All right, so what we want to do is we want to flip that card over, right? We have that initial thing, and we flip those back. We have that initial flip. Okay, we have that click. We want to flip that card over. Then we want to check if any other cards are flipped over that haven't been matched yet. If they are, let's check both of them. We'll say we hit this one and this one. And let's just say one is a pretzel and one is a burrito. Okay, those don't match. So if they don't, we want to flip them back over. If they do, then we want to keep them flipped and be like, cool, you got it. And we'll come to the end game in a minute. We'll say game over when all cards flipped / matched. All right. When all the cards are flipped or matched, that's when our game is over. So this is where the guts of our game are going to be here. The UI was cool. We got some flipping cards, but now we want to set this logic up. Okay, and that's what this lesson is all about right now. So first and foremost, let's create a flip a card over method or function to flip the card over. So it's going to be a little more complex than we had before. We're going to take one of the IDs. We're going to take an ID as a parameter for that card. And then what we're going to do is we are going to check to see in here, find the card, and set flipped to true. All right. We're going to find the card and we're going to set flipped to true. So to find this card, we are going to map over our cards again. React requires that we give it a new set of data for that state. That's how React works. So if we want state, we can't just find the card in there and then say dot flipped equals true. We actually have to map over it, create a new data set, and then pass that new data set back to React. So to do that, we're going to say const. We're going to say new deck, and then we're going to say cards dot map individual card, and we'll look to see two things. First thing is card.id equal to the ID that was given to us, or if the card has not, and I should say, is it an or? And, excuse me. And both of these things have to be true. If the card is not flipped yet, we don't want to flip a card back over. We want to let the computer, we want to let the game do that. So if the card ID matches the ID and it hasn't been flipped over, we're going to do something. Else, we're just going to return the card. Okay, so we only want to create a new version of the card we are flipping over. We're actually changing. So to do that, we're going to return, let's create a new card. New card. We'll spread the contents of our old card out on there, and then we'll set flipped to true. Okay. And in this case, we're going to return new card. I created a variable for that because we're actually going to use it again in a minute as well. After we're all said and done, we're going to set cards as our new deck. And hopefully that deck has changed. If not, then it'll set it to the same old deck because it'll have a return card for each of them. Finally, we are going to pass that down. Flip card, just had to get the name of it. I thought I named it both the same. And flip card. We're going to pass that down to our game board. And we are going to pass that down to our card. Almost there, and we're not going to touch cards anymore. The card.js file after this. Finally, in here, flip card. And I can say flip card, and remember we're passing it the ID. So we're going to say card.id. .id, not div, please. Now, if it works, we should be able to flip our cards over now. And notice that we can't flip them back. Okay, and also notice that this is just flipping our cards over. This is not checking to see if they're matched yet. All right. So we have our cards flipping now. All right. We're getting there. We're slowly getting there, but we're getting there. Okay. I think that this stuff is going to start moving fast through the actual logic of the game. So let's go back to our app. We have that flip card. All right. Now we want to check to see if another card is flipped over. All right. We want to look and see if there are two cards flipped over. Right now, we don't even have knowledge of there being one card flipped over. In this case, we can do this a couple of different ways. That's the fun of development, right? That's the fun of creating this stuff. Is there are many ways of doing this. I could check through the entire list of cards to see if one has been flipped over or not. And if it has, compare it to that. I could store the cards that have been flipped over and then check against that. And really, we can do this a number of different ways. I'm going to choose one way. You might be watching this and say like, oh, I would choose a different way of doing this. Fantastic. Love it. This is just one way of doing things, right? In this case, I am going to store the cards that are flipped over. And then I'll say, I'm going to call this selected cards. And then I'm going to say set selected cards. I'm going to use state. And I'm going to set that to an empty array. Okay, well, currently there are no selected cards. All right. When I flip a card over, I can say set selected cards. And I'm going to spread our state, our original state, selected cards, because remember, we have to have an immutable array or object or string or Boolean or number or whatever we're giving our data to our function or to our state. It has to be immutable. We can't mutate anything. And then I'm going to pass in new card as well. All right. So I'm giving it a brand new array with whatever was in there was spread before and a new card. All right. So now that I have selected cards, we still see that I can flip multiple over. That's fine. There's going to be 10 cards in that array right now. I want to only look to see if there are 2. All right. So what I want to do is I want to check these cards. All right. So I'm going to create a new function called check card. Check cards. All right, I'm going to check these cards, and if these cards are the same, then I want them to stay flipped over, and I want to check to see if the game is won. We'll add that functionality in a minute. If they're not the same, then I want to flip them back over. Okay, so what I'm going to do here is I'm going to say if check cards, and I want to go const first card. I'm going to get the first card out of that array and the second card out of that array. Selected cards. And I'm going to say if the first card dot value equals the second card dot value, then I want to check to see if the game has been won. Else, I want to go through those cards again and flip them back over. Okay. I want to say like, they're not the same card, so I want to flip them back over. So I'm going to say another if statement in here. I'm going to say card, else. I'm going to map over them again. New cards. And then say if card.id equals first card.id or card.id equals second card.id. I'm going to create a new card just like I did in my flip card down there. I'll say new card equals that old card spread, and then flipped is false. I'm going to return new card. Else, once again, I'm going to return the card. Finally, I am going to set cards to new cards. Whew, all right. So there was a lot of overlap between this new deck and this one. Essentially, this is flipping it, and this is flipping it back over. If we wanted to get really serious, if there was a lot of game mechanics going on in here, and we were going to use this multiple times, we would probably want to factor this out and create a function of itself. This isn't the driest way of doing things, okay? But it's going to work for us right now. So we have this check cards going on, and now we want to know when we check these cards. And so we're going to check these cards when there are 2 cards flipped over. To do this, we can actually use something called use effect. It's a hook that will wait until a certain piece of data changes and then check to see or run what we call a callback after that is. So right where we have use state imported, we're going to import use effect as well. All right, and use effect we just write out. Use effect, and we write the callback that we want to run, and then we give it dependencies, what we call a dependency list. All right, and this is going to be items that it's looking at for changing. If it changes, it's going to run this thing. So in this case, we're going to run it on selected cards. So if that array ever changes, it's going to run this. If it doesn't, it's not going to. All right. So in there, we can say if selected cards dot length is 2, then check cards. And that's what we're going to do. All right. So now we should see that our game. Oh, yeah, I forgot about that. So it does check it. Let's refresh it. So it should be checking our cards. If the first value is the second value, keep them flipped over. Otherwise, flip them back. Okay, that should be working. Okay, that worked. Yeah, there was an error in there. Okay. So what we want to do is we see that initial flip. When I click this, the code runs so fast that it doesn't give us a chance to actually see what's on the other side. And it might run too fast that it keeps one in. Okay. So in that case it does. And then there we go. We have multiples in. All right. So what we want to do, oh yeah, that's the other reason. Okay. I got a couple of things that we got to figure out here. Well, you'll notice that I didn't remove any of the cards from selected cards when we found out that they were wrong. So what we want to do is we just want to set selected cards to an empty array. If they're wrong, we want to remove them both. Okay, so now we should see that they both flip over, but then it's going to be too fast for our eyes. Oh, selected cards. Oh, set selected cards. Okay, it's going to be too fast for our eyes there. It doesn't give us a chance to see, unless they're right, what's on the other side. And that doesn't really work out for us too well. Oh yeah, we need to move that all the way down. So we want to remove the selected cards no matter what, because when there are 2 in there, it's going to look to see those 2. So we want to match them, we want to flip them, and we're good to go. All right. So now to get onto that, the fact that they flip over too fast, we're going to give it a little buffer, little time buffer here. And we're going to say set timeout, and we'll give it check cards, and we'll give it a half a second even. A half a second will allow us to see what's on the other side of that card. Okay. So now, there we go. We can see what's on the other side of that card. And now our game is working. We are in the last couple of miles of this marathon of getting this game working. Okay. Ooh, I'm doing pretty well right now. Okay, so let's look and see what other things we have to go over. Okay. If not, flip them back over. Check. We've done that. Card is flipped. Check to see if it's the same card. If not, flip them back over. Increment score by 1. So we don't have a score built in yet, but we just want to see when they are. Okay, we'll build that score in a minute. Let's check to see when the game is over. All right. So we're going to build one more function, and we're going to see if the game is over. Okay. So actually, we're gonna create a piece of state called game1. So we'll say if the game is 1, const game1 set game1, and we're gonna say use state false, false, false. Okay, so when we check our cards, once we check these values, we're going to want to check all of them and see if it's 1, okay? So when the game is 1, essentially think about what state the cards will be in if the game has been 1. Well, every card will be flipped, okay? If every card is flipped, then the game is 1, all right? So what we're going to do is we're going to say... We're going to create a flag that says, has game been 1? And we're going to set that to true. Okay, this is kind of counterintuitive here, but we're going to say it's true. It has been 1. Yes, absolutely. It's been 1. And we're going to prove that false. Okay, so we're going to say cards.for each. And for each is just going to run a... It's going to run a callback function on each card in there, and we'll just say card.flipped. If it hasn't been flipped, then we will say has game been 1 is equal to false. All right. If it has, then nothing. We're not worried about it. So what we're doing here is we're proving that the game has not been 1. All right, we're going to go on each card. If the card is not flipped, if any of the cards are not flipped, then the game is still on. Okay, so we're going to say has game been 1 is going to be set to false. All right, and then we're going to set game 1 to has game been 1. All right. Let's just put something in here to show us that the game has been 1. Let's go an H2, and we'll say game has been 1. All right, so game has been 1, and we're going to, like I said, game 1. And then otherwise, no. We're not going to put anything in there. Okay, the game hasn't been 1. And if we say true here, when the game has been 1, we'll get it. So you're going to watch me play this game once again before we set up our score, and we'll be finished. Okay. Okay, got those. Oh, all right. Has game been 1 is read only. Ah, yes, because I set it as a const. We're going to set that as a let. Thank you. All right. Thought I saw that there. Thought I saw that there. No. Oh. Ooh, looks like we have a little bit of an error going on in there somewhere. Might have that race condition back. We have that open. Okay, we have a little bit of an error going on in there somewhere. Let me try that once more. So it looks like we had one that was able to flip as a single and stay open. That should only happen if we have our selected cards length 2. So that might be a race condition going on. we'll take it slow. Make sure that they have time to flip back over. I keep forgetting where they are. There we go. Okay. Oh. All right. As I said, see there it happened again. Let's check things out here for a second. Okay, so we're checking our cards. Has game been won? It's true. We're going to set game one. We're not concerned about this because we're not doing anything else. If the first card is the same as the second card value. All right. And then let's go new cards. We're going to map the cards, have our card ID, and we're going to flip it back over. All right. Yep. So if it's the same as the first card ID or the second card ID, flip them back over. And then we're going to reset our cards to those new cards. Okay, that should work. Flip the card. We're going to look to see if they're flipped. Let's see. Make sure that works still. We say or. Yep, that all is good. Flip our cards. Okay. The cards are the same. If it's the same ID or it's not been flipped, then flip it. Otherwise, return the card. All right, that should work as well. Interesting. We're going to keep moving on. Hopefully, this will appear itself. It'll make itself known as we move through the rest of this stuff. So what I'm going to do final is I'm going to create a scoreboard. All right. Scoreboard.js. And in this scoreboard, I'm going to import React from React. And then we are going to simply export default function, and we'll call that scoreboard. And we're going to take in some props, whether the game has been won or not, and the score. So we'll just put those in here anyways. Game won and the score. And we're going to return a scoreboard. So the CSS for this, once again, has already been written. Scoreboard. Div that. Okay, and then we'll just leave our scoreboard in here for right now, just like this. Okay. Otherwise, we'll fill it in just a minute. All right, so I'm going to come up here. Once again, I'm going to import our scoreboard from components/scoreboard. And we are going to just give it scoreboard. Okay, our scoreboard is there. All right. And now we want to give it game has been won. We'll give it the game won. We also want to give it a score. And in this case, we're going to just give it, let's just go 10. Okay. So a little bit of logic goes into our scoreboard. We're going to first check to see if the game has been won. If it has, then let's return an H2 that says your game was won. You won it. All right. We're going to have class name. And it's going to be scoreboard score and the winner class on it. Okay. That's going to give us a little animation I'm actually going to copy that emoji because there we go. H2. Otherwise, we're going to say, I'll give it another H2. Sorry, it's a mess right now, but thankfully we have the prettier extension installed and it will clean this up for us. Scoreboard, score without the game has been won, without the winner class. And I will give it a score and include the score in there. Save that and it'll format it for us beautifully. And now we see we have that score of 10 in there. And let's just change this to true and see what it looks like when we do win. Beautiful. All right, game has been won. So game 1, save that. We'll come back in here. We'll create a score. Final piece of state we'll create. Score, set score. And we'll use state and we'll set our initial score to 0. All right. Our initial score will be 0. We'll come all the way back down to the bottom and on our scoreboard, we'll, instead of putting the hard code 10 in there, we'll put in 0 or the score. So we have our score as 0. And now, like I said, we want to see this only when we are don't get a match. Okay. So when we don't get a match, we want to set that score +1. And so we're going to come in here and we're going to say if card, let's go, nope, on our check cards here. So if we don't get a match else, we are going to set score to score +1. All right, so this should now increment our score. 1 second, I'll move this over. Let's get 2 that are wrong. There we go. And now we've incremented our score to 1. Let's play this. See if we can't win. I knew that flower was up there somewhere. There it is. Ooh, that was a lucky break. There we go. And now let's come up here and we should see that when we click that, we win. The game has been won. Okay. One last thing, we don't want it to see game has been won. We want to see what our final score was. So we're going to remove that and we're going to say final score. And we'll have our final score in there. Final score. And then we'll do with our, let's do string templating literals here. Final score is going to be our score. So there we go. Final score is 12 and we have won. All right, so we went through and we created this whole game essentially from scratch. There was some CSS built in for us, right? But this game was built, we created all of the game mechanics and the logic. And this is using just some fairly, I don't want to say simple because I don't think it's simple, but it really is just everyday React stuff. So, you know, we do have some stuff that might seem kind of complex in here, but this is everyday React stuff. So you know, we've created a whole game based on that. I want to give you some ideas on what you can do to expand this. So notice right now, there is no reset button. If we want to reset it, we have to refresh the page. So I would say if you want to continue working on this, build a reset button that maybe resets and reshuffles the cards. Okay, and maybe it keeps a high score leaderboard on there. So a high score leaderboard, a reset button, changing up the emojis for images. Maybe like, you're really into Star Wars, or you're really into Pokemon, or you're really into something else, right? And you're like, cool, I would love to do that as Pokemon characters. And you can have all of the Pokemon characters. Some other ideas I think that would work really well for this game would be including something like a difficulty level. So you can say maybe an easy difficulty is 6 cards, and maybe a hard difficulty is 50 cards, right? Go even up from the 20 we have here. Okay, so there are a lot of things you could do with this. Maybe flashcards. Maybe you have 2 terms that you want to link together, and then underneath them will be a symbol. And so if you link them both, you're like, okay, cool, I got those too, right? There's just a world of possibilities out there of what you can do with this type of thing. And also there's just a world of possibilities of what you can do with web development and software development in general. If you're here still, you obviously have been enjoying this. I hope that your brain is really thinking of the different things you can do. This is a really simple memory card game, right? But you're probably into this. You're probably either into development or you are intrigued by what we're doing with it. I'd recommend you come check out Lambda School's programs. We are, running full stack web development programs. As I said, you can build this about halfway through the program, and we keep getting out more. So I'd highly recommend you go to lambdaschool.com, check it out, learn about our programs, reach out we have tons of great people, great staff hanging out, standing by. You can reach out to me. I'm Dan at lambdaschool.com. Attend more of our events. Check out what else we have. It's not just games. It's so much else too. We have hold regular open houses, previews that let you experience what our school is like in the day-to-day. And talk to an enrollment advisor. Talk to someone that can help you determine if it's the best fit for you, if this program is going to work for you. So come on and join us. At least learn more about what we're doing and what we're doing in software development world. We have web development and data science courses going as well. It's a really fun, engaging career path to go down. It's great because, like I said, the possibilities are endless. You can build so many things, and really it's just to the extent of your imagination. Like I said, with the stuff we did today, we can build a lot of popular web applications that you're using on the day-to-day, and just the concepts we have here. So that being said, love to open it up to a couple of questions. And we're going to have a couple in here. So where do we get the flipping animation? That's a great question, and that's going to be in our styles. So let's remember that this card is going to have 3 parts to it. We have this outer card that really is our, that's just going to be our ability to put the click event on. We have the inner card, which is going to be what our card looks like. And we have a back and we have a front. And we can imagine that the back and the front are 2 pieces of paper stacked on top of each other. The back is flipped over already, and the front is facing the front for us. Okay. There is some CSS in there that helps us out with that. And like I pointed out here, it's the back face visibility. So this is saying when it's flipped over, If the front's flipped over, you won't be able to see it. And if the back's flipped over, you won't be able to see it. And since the only one of them will be flipped over at the same time, you'll only be able to see one of those faces. And so the card back we can see here, we've already transformed it 180 degrees. So it's already flipped over. So the back is invisible at the moment. And when we flip it, what we're doing is we are adding this transform to the whole card. Okay. And so that's what flips it over at 180 degrees. And now the front is invisible, but the back is visible to us. So it is, a little bit more advanced CSS. If CSS is your thing and you'd like to learn more about it, by all means, all the CSS styles are in here and go through it. But yeah, that's how the flipping animation came. Let's see. Would you want to break out of the for each if it comes across a card that isn't flipped instead of having to check all the cards for no reason? That is a fantastic observation and a great way to enhance the performance of your application. So when we find, let's say we find that right here, let's go right here. So we find that the card has not been flipped yet, or and that the game has not been won. So why are we going to go through the rest of the cards? This is a great place to find and refactor your code. Say like, if you had 100,000 cards here, it's probably pretty performant to change that up and to make it so that only once that card has been found, it's been hit. We have 20 cards, so it's not that big of an issue for us, but that's a great thing. Always be looking for those little places that you can change up the performance of your application. Okay, so great observation. What's the difference between a double equals and a triple equals? You'll notice that I use triple equals for almost everything I do. So I could talk about this for a long time. And if you're in one of my classes, you'll probably hear my rant for a long time about it. But in JavaScript doesn't have the isn't a strongly typed language. So when we're comparing two items, JavaScript allows us to do something called type coercion, where we can say like, I know this isn't a Boolean, this is a number, but I want you to pretend it's a Boolean, and JavaScript will do that for us. It's a place that a lot of beginners, and to be quite honest, a lot of professionals get tripped up quite a bit. Triple equals is going to check a couple of things. Number one, it's going to check that these two items are the same type. So in this case, that ID is going to be a number. So it's going to make sure that that's a number and that's a number. And you're going to say, well, Dan, is that ever not going to be a number? And I can say no right now, but I don't want to be able to have to say no in the future if I don't know the places that this application are going to go. So it's going to check the two of those to make sure that they are both numbers, and then it's going to check to make sure that they are both the same number. Because just to show you, if one of them wasn't a number and it was 12, or was the number and it was 12, and I had a double equals, and then I had a string with a 12, this would be true. With double equals, that would be false with triple equals. Okay, so that's the difference between double and triple. Just as habit, and just to make sure that the issues like that don't come up, I always use triple equals unless I'm trying to do something very specific and using type coercion to my advantage. Then I'll use double equals. But in JavaScript, it's best to use triple equals at all time. What are your best and most popular classes in Lambda School? Well, right now we have a full stack web development course, which is what I teach, and that goes through the entire full stack. So this is considered front end, even though we're writing code. A lot of people think this is considered back end. So you get this full range of what we do in web development. We go through React, we go through advanced React, and then we go into back-end development as well, and we use Node or Java for our back-end development. And so you get the full picture, and by the time you're done, you have the you'll have the ability to create a full web application. We also have data science course. I am not a data scientist, so I can't talk that eloquently about data science. But our data science essentially is the same length of time. It's 4 units long, what we consider 4 units, and then also has a computer science aspect and our labs aspect. If you're interested in that, in either of them, come and talk to us, lambdaschool.com, submit an app, or just reach out to us. I'm more than happy to talk about the differences and the intricacies of both. If I have no experience with coding, would you recommend web development over data science? That depends on what you're interested in. It really does. I get this questions a lot. Both are going to require a lot of coding, and there are different levels we'd like people to be at for each. But really, it comes down to your interests. Is building something like this more interesting than analyzing a ton of data, learning from it, and building amazing visualizations with it? It really depends. And I think that the best way to get started with that, and the best way to understand that, is number one, do some Google searching on both of those things. Like, what is web development? What is data science? Number two, come talk to us. We can put you in touch with our data science instructors, with our web instructors, and help you understand the areas that you're most interested in. Because I'm not going to lie, if you're not interested in something, then just because it pays a lot or just because something else, it's really hard to stick with that kind of thing. Finding something you're interested in and passionate about will keep you motivated and keep you going. And then at the end, you get a job doing something you love doing. So really that is kind of a tricky question, but yes. How many months does it take to learn full stack web development? So our class is 6 months long, and I got to think of our 4 units. So that is essentially 4 months of web development. Then we have a month of computer science fundamentals, where you learn things like data structures and algorithms, and the things that really matter, that are driving what we build in web development. And then you have a month of labs, which is a collaborative, essentially you are put on a software team and building in a software environment. So 6 months for our full-time program. We also offer a part-time program in the evenings, and that program, because it's only 3 hours a night, it's a little bit longer in duration, but it also allows students to have full-time jobs or take care of family commitments, and that's a year long for the part-time program. So there you go. 6 months for our full-time and 12 months for our part-time. Why is it complaining about selected cards in your dependencies list? There we go. Oh, I didn't give it a key. So these are warnings. There are a number that I should be paying attention to, but also notice that these are ESLint warnings. These aren't coming from React. And so it's what's known as a linter, and it essentially is just best practices. If this was production code, I would go through and fix every single one of these warnings. But since we're just trying to get things working on the screen right now, I'm going to ignore the warnings for now. If it was an error, it wouldn't render. We'd have to select those. So why is it asking about selected cards? Because it wants me to put check cards in there as well. But that's going to take a little bit more time, not give us any performance help, and not change anything that's going on right this second. You will learn more about that if you come into our full stack web program, and you can check it out as well, the use effect dependency list. All right, everybody, that's all the questions I have tonight. Thank you so much for joining me. If you are happy with the game you've created, I suggest going over into the deployment section and doing a one-click deploy to Netlify. That's going to deploy it to the web. And then you can just take that code or that URL. I'll show you the one I have. No, I haven't deployed it right. Let's do it again. Okay, so that should be my new deployment. And you can share that, of course. It'll take a minute to update. But you can share that with family and friends and be like, look, I built this game. Pretty awesome, huh? But thanks for joining us tonight, building this little game in JavaScript. It's been a blast. It's been fun to be with you. And have a great night, everyone. Good night.